Hi and welcome back. For a while now I've been looking for a few cheap broken CB radios for me to repair and tune up. The plan is to buy a few scrap CB radio chassis and get them fixed and tuned and working. Now to do this properly I need a few test instruments. First and foremost an 8-digit frequency counter and secondly an FM signal generator. I already own a couple of oscilloscopes and a power meter, so I'm good there. I will use the RSP1 SDR to check the transmitted deviation and the received audio. So firstly I ordered the frequency counter. This model is found badged under different names from anywhere between £50 and £80 on the Chinese marketplace and represents probably the cheapest new bench frequency counter you can buy, with the only downside being its relatively slow gate time. But in practice I haven't found this to be a problem and to be honest it seems pretty accurate. I'm still awaiting the arrival of the FM signal generator. This is needed so that I can check and adjust the receive sensitivity of the radios, and bearing in mind I will also use this to check my other radios as well. It will provide an FM signal at adjustable power levels, enabling me to set the receiver sensitivity and the squelch and the S meter on these sets. I bought a 30 dB attenuator and a cable to enable me to connect the CB radios directly to the frequency counter. It's very important that you do not transmit directly into test equipment unless that equipment is designed and rated for the power transmission being applied. What I wasn't prepared for, however, was the price that these non-working, second-hand and in some cases 40-year-old CB radios were fetching. Now, having bought quite a few vintage CB walkie-talkies in the past, I figured that they weren't going to be giving them away, but even scrap chassis with nothing on them were fetching silly money. A quick look at eBay here and setting the search results to show items that have completed or sold, used and non-working. You can see that even a simple switch can fetch up to £20. Now, having two working sets here and an outside antenna, at least in my area, I know that people aren't buying them to use because nobody is ever on it. So are all these people buying sets just buying them as collectors, or is there something else going on? One of the very first CB radios that caught my eye back in the day was the Midland range of radios. I think that it was the styling and the colours. I'm not sure if it was intentional on the part of the manufacturer, but they styled this range of radios similar to many ham radio designs that were popular at the time, such as the Yaesus. Maybe trying to kid CB operators a little with this, I think. The first radio that I bid on, I did win. This radio was sold as not working and for spares or repair. Even then I had to bid and pay up to nearly £50 for this radio. Back in the day from new, this radio, the Midland 3001, would sell for about £70 UK equivalent. So here I am paying just shy of £40 to £50 with delivery all these years later for a non-working radio. I guess you can see my point here. Anyway, the Midland 3001 was the middle spec radio in a range of radios called the Precision series, and although the external look of the radio was different to nearly all of the CB radios at the time, the internal chassis was a common design based upon the Maxon chassis, which was also used by Colt and Cobra and President, to name just a few. I think one of the things that I noticed most about this line of radios was the microphone. Most CB mics at the time were just a square, uncomfortable black angular device with silver writing on the front denoting the brand. The Midland mic was much more rounded and professional looking, and it was in fact the same case that was used on many Midland marine radios that I had probably not unconsciously noticed and seen years before sat staring into the wheelhouse of cruise boats while on holiday down in Cornwall. Now, this range of radios was produced in both AM and FM variants. Something to look out for if you are in the UK, as many people sell them on eBay as UK FM sets when in fact they are not, so it's worth checking. I have seen variants with the 2781 front fascia that are not FM sets, and whilst AM sets can legally be used in the UK, there really is little point as foreign and local interference makes them pretty unusable. The 3001 is pretty basic. It has a volume on-off switch, channel indicator, backlit S meter, a local or DX switch. All this did, in fairness, was to enable the RF gain facility, which is also adjustable. It has a manual squelch control, a PA switch which basically lets you connect an external speaker so you can shout at people, and a filter switch which basically adjusts the tonal quality of the received audio, a treble or bass filter if you like. Unusually for the time, the channel readout was green as opposed to the usual red displays seen on other sets. Also, the S meter was green when illuminated. Many second-hand sets are shown with the wrong S meter in, as the bulbs easily blew, particularly when the radios were overvolted or used on farm vehicles, etc. And they were replaced with non-standard S meters with the warm white version. Anyway, let's dive right into this radio and see what we have to do here to get this thing working. Right, well, it all looks pretty clean inside here. What I'm looking for initially is any sign of any modification work or extra wiring, and I can't see that there's any here. There's some evidence that the regulator has been changed there on the side of the case, but other than that, it looks really clean, and there's no evidence of any tampering or soldering being done on the back of the board. It all looks pretty much as it should do as it came out of the factory. I think it may have been used in a smoking environment, possibly. It does slightly smell a little bit, but it seems all there and intact, and we shall find out whether it's working or not. Of course, the radio was supplied with the original Molex type power lead, and this had obviously had the fuse go or chopped out of it and replaced with the chock block. So we need to make that safe and good. So I fished out some old parts from my parts drawer. I've got some fuse carriers I've had for quite a long time there, and quickly soldered up an inline fuse holder to put a 5 amp fuse in. And we just dropped that down here to show you, and I didn't have any black, so we used blue. It's my radio, so I shall do what I like. Anyway, we're going to do the testing here with a current limiting power supply and see how we get on. Right, we've got the CB connected up. We have it plugged into a dummy load. I'll just turn the other power supply off. We've got the current limiting power supply connected, and we are doing this initial test into a 50 ohm dummy load. Now, if you know anything about testing power output, you don't test power output into antennas, you test it into purely resistive load to get the true output power indication of the radio. So that's a little tip for you there, and we'll have a go at seeing if this radio fires up. The seller said there's an issue with the PA switch. When you wiggle the PA switch, the radio sort of switches on and off, but I'm not so sure. So let's give it a try. We've set the power supply to 13.2 volts as per the manual. Straight away it comes on. Doesn't look like there's a bulb. It looks like the bulb's gone over the meter. Unless I get the lights off. Let's just switch the lights off. Yeah, it's certainly gone. Or if it's not, it's very dim. Anyway, let's put the light back on. Light back on. Okay, let's get a bit of volume. So CBPA, let's see what he says there. There's a bit of a delay in between the two, so I'm going to give those switches, all the switches and knobs, a bit of a clean. That doesn't seem too bad, but I've got some switch clean, and I'm going to go through the switches and give them a clean. Seem to fix that problem. I seem to fix that okay. Alright, let's see if we can test that. Some switch cleaner in there. Local and DX switch on the front there. And RF gain and switch. So let's see if we can get anything on the power meter with it. Okay, right, it's going into transmit. And just over 3 watts on the not so calibrated Zetagi power meter, but we'll just, obviously when we tune this, we'll be tuning it for the optimum power. There is a very high pitched whine coming from this. I don't know if you can hear that. Not my stomach, that high-pitched ringing sound, and it goes when you key up. It's just on receive, so I'll have a little look at something there. Maybe might need to do some capacitors on this radio. Right, as I suspected, the ringing on receive was being generated by the current limiting amplifier. So I've put it onto the switch mode, and seems to have got rid of that problem, and the ringing noise has stopped. So there's no ringing noise now. So that was obviously that. Testing 1 2 1 2. Okay, so it seems the deviation's a little bit on the low side, but we'll check that. Right, we're going to desolder the wires off the speaker because we're going to get the radio connected up to an oscilloscope, and I've got an FM signal generator on the way from AliExpress, so we can actually set this thing up properly and get it on frequency and everything. I've also got a frequency counter coming as well, so I can't actually do any more until those bits arrive, but they're due any day. So the point with this was to just get as far as I could with this, get it basically transmitting and receiving, and then do the tune up. So we'll do one more test with it before I take that speaker off. We'll just make sure it receives, and then the next part of the video I'll have to wait until I get the meters coming from AliExpress. Testing 1 2 3 4 5 5 4 3 2 1. Testing. Feedback 1 2. Oh, it's working. One very minor little thing, the small screw out the microphone lead has popped out. I've actually got a new plug. I'm not going to swap the plugs over, I'm just going to pop the screw in there. I want to keep the original plug. I'm giving it a clean and it all seems good. At the same time, I've also given the potentiometers and the trimmers that you see on the board there a good squirt as well, because they've probably got a bit corroded and dirty over the years. So we'll swap this screw over. We'll actually take the microphone apart and give that a bit of a clean. Like I say, you can see from the screws on the back here, it's probably been kept in a fairly damp environment at some point in its life, and it's got one non-standard screw there. So we'll take it apart, we'll give the switch a clean with some switch cleaner, and we'll see what's hiding inside. Very definitely not a proper screw. A self-tapping wood screw. People will fit anything, wouldn't they? Right, let's have a little look in here. Oh, looks surprisingly clean. Got a little bit of paper stuck between the contacts there. Not quite sure what that's up to. Holding something in, possible. And the microphone is held, appears to be loose, but it's held in place by this foam pad on the back of the handset there. Let's just have I'll have a little look at this switch arrangement and give it a clean and see if I can work out what this bit of paper was doing. It's probably holding one of these wires on. So we'll probably resolder all these and then pop it back and just test it quickly. So removing these 3 screws around the microphone insert, excuse me. Removing these 3 screws around the microphone insert drops the microphone out, and there's the coil microphone, dynamic microphone, and there's the bezel shield with the pop filter, I suppose you would call it, on the other side of it. It looks fairly clean. And doesn't look too bad at all, that, so that's okay. I don't know what that piece of paper was doing. There doesn't seem to be anything untoward, focus, untoward with the switch connections. I'm going to give them a bit of a clean, give the switch a clean,
and then just reassemble it, because I think it's actually fine.
Right, with the mic reassembled, I didn't like the way the mic still rattled around inside the case. The foam padding wasn't holding it on, so I designed a little clip, and I thought I might need 3 of these clips, but I decided a little clip to use the existing screw to keep the microphone still and hold it down. I printed off 3 of these, but actually after fitting it I only need 1 just at the top there, and this now stops the microphone moving horizontally and vertically, so it doesn't rattle anymore. So that's the first thing, something that's been designed for this video for a while, that's for sure.
It's in my old box of stuff. I've got these screws. It's a bit shinier, a bit nicer than these rusty old things. I know these were the original screws, but they're going. I'm putting some nice shiny ones in. Well, that's instantly a lot better. The centre screw I just cleaned up and then fitted the 4 new screws in there. And before anyone says anything, those actual screws, those ones there, came from when I was a young apprentice, so they are quite old, those screws. At least about 25 years old anyway. So yeah, they match the age of the CB almost, and they just look a lot better than those rusty old things, don't they? So that microphone is all working 100% now. Clean the contacts in the plug. The wiring seems pretty good in there. The actual cable itself, it's actually not too bad at all. I've seen a lot worse on second-hand radios, and I've sold quite a lot of second-hand radios in my time. So yeah, I'm pleased with that. That's come out nice. That's perfect. Now just got to wait for the FM signal generator and the frequency counter to come. So the FedEx man finally arrived, and we got the Victor VC3165 high resolution frequency counter. This apparently will do 0.1 of a hertz up to 2.4 gigahertz. So this will be really interesting to see how well this works with some of my radios. So we'll get it plugged in, see how we'll get it plugged. That's just the stand coming out. We'll get it plugged in and see how accurate this this radio is. Took the signal meter out because the bulb's gone in it. The that focusing there, little bulb's gone in there. I'll just test the continuity, but I should be able to stick a diode replacement in there, a bit brighter. Just need to find a nice warm white colour. The LED in there. Right, place the LED. Looks a little bit better now. How about that? Blow your socks off. There we go. It's nice and bright now. Right, to set the VCO to 10.24046, we put the frequency counter onto pin 12 of the LC7136 oscillator chip, and we measure off of pin 12 to get as near as we can, plus or minus 100 Hz. So there's pin 12 down here. Right, to set the VCO, we've adjusted the capacitor there, the variable capacitor, and then we're measured with the frequency counter off of pin 12 of this chip to get as near as we can to the reference of 10.240 10.24046 megahertz plus or minus 100 Hz, and we're pretty close, as I'll show you. I've got my probe on the pin 12 at 10.24045, absolutely spot on. I did take a little bit of adjustment, it was slightly out. It's obviously drifted over the last 40 years or so. Right, quite a lot to get through there, and I don't want to keep you any longer today. So that's the end of part 1 of this 2-part series. I hope that you've enjoyed and or picked something up from this first video. I have a few spare 3D printed mic clamps if anyone wants them. I'll send them out free of charge. I know you can just jam a few matchsticks or pieces of paper in there, but we don't do things like that here, of course. On the next episode, we'll see how much power we can pull from this old radio,
We'll test and set up the receive sensitivity, and we will then do a field test with this radio back to base against the Thunderpole T800 radio. I have about a week to wait for the signal generator, so keep an eye out on your subs feed for the video in the next couple of weeks. In the meantime, have fun, stay safe, and if you have been, thanks ever so much for watching.